Good evening, everyone. In electrical substations, one of the main requirement is to troubleshooting the circuit breaker electrical problems, like control circuit problems, like that. So for that, we need to understand. First of all, we need to understand how to read the circuit diagrams. Like here, I can show you this is a 11 kV make breaker control circuit, likewise CT circuits, metering circuit and production circuits. This is the AC circuit and this is production circuit. So first thing is we need to understand how to read a drawing and how to troubleshoot the fundamentals of the troubleshooting of the problems. So for any electrical network, any electrical circuit, we can classify the components as follows, mainly three components, namely one is supply, whether this is AC or DC. Usually in 66 kV and below substations, the DC controlled DC voltage will be 110 volts DC, and AC for single phase 230 as usual 235 volts. Then switch, then bulb. This is the fundamental. So as you already know, okay, so supply and switch and bulb. Any complex network can be converted into, simplified into these three components, consisting of these three components. In our substation electrical control circuits, in the place of bulb, it may vary. It may be tripping coil or closing coil or master trip relay, indication bulbs, annunciation, fascia, like that. So the concept bulb is means load. So the components may vary depending upon the circuit. And supply, it may be 110 volts DC, usually it will be 110 volts DC. And switch may be auxiliary switch, which we will learn in depth in later cases. And auxiliary switch, TNC switch, and then like that. So we will learn particularly the drawing in the later cases. Okay, so only mainly these three components, supply, switch and bulb. The positioning of these three components may be situated in the different components of the electrical system. Likewise, for an annunciator fascia in the remote annunciation desk, the supply will be fed from the annunciator fascia itself, and the switch will be in the breaker, and bulb will be in the annunciator fascia itself. Like that, it will, the positioning of these three elements vary. So let us assume that the supply voltage is 110 volts DC. So that means here this side 55 volts plus 55 volts and this side minus 55 volts DC we have given. So if we measure the voltage across this point, open circuit voltage, it will be 110 volts DC only across the switch. So positive voltage whatever we have applied here will come and will be here in the open circuit voltage. Likewise, negative voltage minus 55 volts DC will be ready here. Hence, if we measure the voltage across the NO contact, means that switch, we will get the full voltage. Full voltage we will get. Once the switch is closed, this positive voltage will appear across this and negative voltage will appear across this. Then we will get the full voltage across the bulb. So this is the concept. So after understanding this concept, let's understand simple electrical circuit like breaker control circuit, like tripping mechanism of the tripping circuit of the breaker, trip circuit of let us first learn 11 kV breakers. All 11 kV breakers will be having common elements in the tripping circuits. So positive, this is 86, also called master trip relay, and then this is 52A, and then tripping coil. So here K1, K2. So 110 volts DC will be applied here, means plus 55 at K1 and minus 55 volts DC at K2. So this is the tripping circuit, this is tripping coil. 52 means 52 is the ANSI number code for the circuit breaker. 52A means NO contact of the auxiliary switch. This is auxiliary switch. So it will be like this auxiliary switch. What's the purpose of this switch? This switch is operated by mechanically operated switch. This one you can observe. This is the bridge between electrical and mechanical circuit of the breaker. That means it tells the electrical circuit that what is the status of the circuit breaker, whether it is in closed position or it is in tripped position. So for example, for electrical circuits, we need for red indication, we will be giving red indication for breaker CB on condition and green indication for off condition. For that, we need to know the status from the mechanical circuit. So this is the bridge between electrical and mechanical circuit, and the specialty of this switch is that it is a diagonally opposite switches, like A12 and this side A11. These two are single contact. Okay, these two are single contact. Here you can observe that these are spare contacts actually. U1, U2, U3, U4. These are all NO contacts. 5 NO, 5 NC. Like A11, A12, A11, A12 diagonally opposite. Likewise, diagonally A19 and A20, this is diagonally opposite contacts. So this will be operated by the operating rod, which is connected to the breaker mechanism. So whenever the breaker charges, the position of the auxiliary switch changes and trips again reverse. like this it works. So now you got to know what is auxiliary switch and its significance in the breaker control circuits. Okay, so when this is a very simple circuit, very simple. One switch is there, okay, not one switch, two switches are there, and one bulb, that means tripping coil, and the supply. So this 86 MTR will be operated once this master trip will be operated from the relays, and 52A will be in closed condition when the CB is in on condition. So 52A is now NO and it will get closed when CB is on. So once CB is on, the negative voltage which is available here will travel and will be available here in this point, minus 55 volts. Likewise positive voltage. Then if you measure the voltage across the 86 contact, you will get 110 volts DC. So once the 86 contact operated, then tripping coil will get electro will become electromagnet, energized. Tripping coil will be energized and it will become electromagnet, and it will operate the latch of the mechanical mechanism, thereby trips the breaker. As soon as the breaker trips, this 52A, which was earlier in closed condition, will become open. Once it's open, the circuit breaks. Usually our 86 relay will be hand reset type. That means unless the operator goes and reset the relay, it will be in closed condition only. So another significance of the auxiliary switch is that it breaks the continuous command to the tripping coils or closing coils. Once breaker changes its position, means once tripping purpose is done, this contact will become open. Then even though it is closed condition, the supply cut off to the tripping coil. These tripping coils are just short time. They are designed to operate for the short time, more torque, more power. Like that, if we continuously give 110 volts DC to these tripping coils, they may get burnt out. So this is short time, around short time operating elements. So this is 52A auxiliary switch. Okay, next we will add another element to this tripping circuit, that is TNC switch. Okay, another contact of TNC switch. So TNC switch means strip, normal, neutral and close. Here we have one TNC switch, you can see, new one. Here trip, neutral and close, breaker control switch. So this is used to trip the breaker. Here, unlike the auxiliary switch, this TNC switch is directly opposite. Contacts are directly opposite. That means 1 and A are one contact and 2 and B are another contact. So let's see. Let me put the continuity mode. Now trip. So only when I rotate towards the trip command, trip comes. So 1 and A are the trip contact. Likewise 2 and B. Two and B are the close contact. So this is the TNC switch which is used to trip the breaker or close the breaker. Okay. So usually there will be two numbers of TNC switch. One will be in the local control panel and another one will be from the TNC remote annunciation desk remote. So for this, for the selection purpose, we will be having one local remote switch. So for if it is local, if it is remote, that switch gives the option to either to control from the local or from the remote. Okay. That's it. There are only three switches, well, three controls. One is from protection purpose, another local control and remote control. So only via this only tripping coil gets the current or voltage. Okay. If you, in some cases you might get the problems like continuous DC command to the tripping coil. So in that sense, in that cases, you should concentrate on these three components. Only via these three the voltage can come to directly. So whether it maybe get shorted, this contact maybe get shorted, like that. If you isolate one by one, you will get where is the problem. After understanding this, we will directly go to the circuit. In the circuit you will see this is J4 and J3, J5 and J6 is the main DC. After fuse and link set, this is link symbol, this is fuse symbol, and these are parallel circuits. So we will be concentrating only on the this circuit, trip circuit. Okay. After FS1, K means control DC. The voltage here it is master trip relay, and then K3, and then this is trip circuit. Likewise, this is local and remote switch. Local and remote switch. You can observe here the black rectangular boxes here. Black rectangle boxes here. Local means whenever we kept the local remote switch in local mode, these two contacts will make, and these two will be in open condition. So these two contact and these two contact will be in closed condition. So this TNC switch, this is local TNC switch will get the supply. Here also TNC, if you turn towards the tip side, this contact will get make. When you turn towards the TNC switch towards the closed side, this contact will get make, and it will give the pulse to closing circuit, and if you make trip, it will give the pulse to tripping circuit. So let's go to tripping circuit. Again here same K1, after fuse K1, and then this is local remote switch. Local means these two contacts will get make, and the voltage will be readily available in the K51 and K41 terminals, positive voltage. Once you give T and C, T means this contact will get closed, C means this contact will get closed. So T, this contact will get closed and positive voltage comes here. If the breaker is in closed condition, this A contact will be in closed NC. Hence, command extend to shunt trip. This is tripping coil. So tripping coil will get energized and the breaker will trips. As soon as the breaker trips, this A contact will get open. It will become again open and thereby avoiding the continuous DC command. If it is operated from whether even though you have given continuous trip pulse, it will be open. So this is the tripping circuit. In trip circuit of the usually 11 kV breakers, they are vacuum interrupters. So only components in the trip circuit of the 11 kV breaker are, we can categorize components of trip circuit of 11 kV breaker. Number 1, tripping coil. Number 2, auxiliary switch. Number 3, master trip relay contact, master trip relay output contact. Okay. Number 4, TNC switch local. Number 5, TNC switch remote. Number 6, local bar remote switch. Only these components will be there in the 11 kV circuit breaker control circuit. Only these components. So how to troubleshoot now if only these components are there? For example, breaker is not tripped, relays are operated, breaker is not tripped. Excuse me.